In this exercise, we're going to look at solving trig equations, and we're going to look at lots of different methods. As you can see, here is method 1 and there'll be method 2 and so on. And while we're going to separate the techniques into different methods, can I always encourage you to think about solving an equation by using a graph. Now, we know the obvious problems with graphing to solve equations is it's not very accurate. However, there are some times with trig equations when they don't so much want the exact value that would solve the trig equation. They sometimes just ask how many solutions would there be. And if you think about the graph and this particular example that says solve sine theta minus 1 equals 0, obviously it's an equation. We're solving for theta. It's a trig equation. We know that sine theta has to equal 1. So theta is equal to sine inverse of 1. Actually, that is because it's such an obvious value for on the graph that we're looking for when the angles when sine is 1. It's very easy to actually read them off as 90 or pi on 2 if we're in radians, etc. Also pointing out here that, whoops, that's not very good. It says, what do you notice about the answer? Well, it's pi on 2. It's over here at what's 360 plus 90, 450. There are an infinite number of answers to the angle that has a sine equal to 1. So what you're going to find is that because we're not expected to give an infinite range of answers, and we're going to see later a way to actually write that. For now, you're going to see that you're going to be given a restricted domain. So expect some restriction on the x values or the values of theta according to the equation that's given for you to solve. So it's this sort of thing. Theta is only between 0 and 360, for example. So if you scroll through, you'll see that there are, I think, about 5 different methods. And the really important thing for you then, once you've worked through what the 5 methods are, is I guess the important thing is for you to then decide, well, how will I know which method to use? And the answer to that is you'll know what method to use depending on what the equation looks like. So not only as you go through these examples and do the questions from the textbook, are you focusing on mastering the method, but you've also got to register what the question looked like, because there's no official 5 methods for solving trig equations. You won't find that anywhere. I've just tried to break down and put into categories the different types of equations you could get, different types of trig equations that you could get that you could be asked to solve. And by looking at each one of those in those categories, then it just gives you some structure to the way that you will approach a question that says that it is obviously solving a trig equation. So firstly, you will look at special features of the equation, which should then direct you to the method that you will use. The interesting thing is that almost all methods come back and to this quadrant method. So you're going to ultimately need to solve for an equation where theta belongs to a particular quadrant, and you need to be able to find the quadrants that theta belongs to. So what do these particular equations look like? They simply look like trig ratio of theta, the unknown, is equal to a number, a ratio. And there is, like we said, the restriction on the domain, or the theta. Theta is the variable in this case. And so we're able to restrict our number of answers that we give. Now, remember I said that almost every other method eventually comes back to a line or progresses through and produces a line that looks like this, that the trig ratio of your unknown is equal to a number. So knowing that all the other methods are going to eventually look like this one, you can see the importance of being able to master how to solve this type of equation. So there are a few things to note. And I guess one of the most important things to note is the sign of the number. The cos of the trig ratio of the unknown angle is it a positive or is it a negative? The reason for that is it allows you to identify which quadrant that we need to work in. So always begin your solution with a quadrant diagram. And by that, I just mean this: quadrant 1, 2, 3, and 4. Once you've got your 4 quadrants, decide which particular quadrant you need to be in based on the connection between the trig ratio and the sign of the number. Is it a positive? Is it a negative? So as in this example, you can see it's a cos ratio and it's a positive number. Don't worry about the numbers yet, but just the cos ratio, and it's positive. So we know that all trig ratios are positive in this quadrant, and using, as it says, all stations to central, the other quadrant we need to be in is here. We know that in those 2 quadrants, the angle is there, the acute angle is there and there. So, knowing that, if we have to use our exact ratios, then we will recall the 2 little triangles. Otherwise, we'll go to our calculator. Remember, first quadrant, all angles are just called theta, the acute value. And for this example, in the 4th quadrant, all angles are defined using the 360 minus theta. So we've got the cos theta is this √3 on 2, and we're in the 1st and the 4th quadrants. Now, some values will become very familiar to you very quickly. This √3 and 2, and for some of you, I'm sure already, you make the connection when you've got a √3 and 2 to this triangle where this is 60, this is 30, the length of the sides are 1, 2 on the hypotenuse, and √3 on one of the other sides. So we can see that the cos of 30 degrees would be √3 on 2. So I can say theta is 30 degrees. But I also know that cos is a positive around in the 4th quadrant. In the 4th quadrant, we name our angle as 360 minus the acute angle. So using that, we can see that we want 360 minus our 30, which is 330 degrees. And if you do so happen to get a ratio that you recognize as one belonging to these exact value triangles, then you can get your answer straight away. You don't need your calculator. I think I will stop the video there because it's now getting a little bit long, and do the rest of the examples in another video.